Okay, good morning. Welcome to
FunMath number 197.
FunMath number 197. I need to start this one over because I drew the triangle wrong a second ago. So this is A, B, C like this. Point P is chosen randomly inside an equilateral triangle. What is the probability that the area of APB is bigger than both the area of CPB and APC? Okay, so to make it easier, I've called triangle APB1, APC2, and what did I call it? CPB3. Okay. So, how would you want to approach this problem normally? A probability problem.
Well, we approach it normally by doing the number of good outcomes over the number of total outcomes.
Okay, so normally we want to say the number of good outcomes over the number of total outcomes. But why doesn't that work here?
There's infinitely many places P can go.
Right. The problem is we can pick P in infinitely many places. And that's going to mean it's going to take a long time to count the total outcomes. Also, it's going to take a long time to count all the good outcomes.
It's hard to divide infinity by infinity.
Yeah, it's hard to divide infinity. So we got to figure out some other strategy here. Okay, so what do you think?
Well, if we put P kind of in the middle,
okay,
all three triangles would be equal since this is an equilateral triangle.
Ah, okay. So the fact that we have an equilateral triangle here is actually important. If we put P in the middle, all three of the triangles will be the same size. And how do you know that?
Well, because the outside big triangle is an equilateral.
Because everything's going to be symmetric here because this is an equilateral triangle. Would this work in a 3, 4, 5 triangle?
No.
Not necessarily. It'd be harder to find what the middle of the triangle
Yeah.
was. But the middle of an equilateral triangle we can find. Okay, so that's an interesting observation. So if we pick P in the middle, all three of the triangles are the same size. Alright, what now?
Well, now, if P's in the middle, and we move P along this dotted line,
Yeah,
it'll make triangle 1 bigger and triangle 2 and 3 smaller.
okay.
But if we move it on the other lines, it'll make 2 and 3 bigger.
And 1 smaller.
Yeah.
Okay, so what does that give you a hint as to what the answer might be?
Maybe 1 out of 3.
Okay, it looks like 1 out of 3 times
Marker's losing its ink.
triangle 1 is the biggest. Okay, now how can we convince ourselves that that is right?
Well, this point P that we picked here will make triangle 1 bigger than 2 and 3.
Yeah, that's why I drew it to show triangle 1. What can we do that helps us understand that 1 out of 3 is the right answer?
Well,
Think about this point in the center. That helps us think about the symmetry here. What can I do?
well, when P's in the center, all three triangles
Are the same. How can I make turn triangle 1 into triangle 3 by using this point in the center? What can I do?
What do you mean turn triangle 1 into triangle 3?
Rotate the triangle. See what happens?
Yeah, you just spin it along at the center point.
Okay. So triangle 1 I can turn into triangle 3 turns into triangle 2, and triangle 2 turns into triangle 1. You see that? Okay. So anytime I do something that makes triangle 1 the biggest, I can rotate it, and that's going to mean triangle 3 is the biggest. Does that make sense?
Yes.
Okay, so anytime triangle 1's the biggest, there's a configuration where triangle 3 is the biggest, and similarly a configuration where triangle 2 is the biggest, right?
Yes.
So what does that mean?
That means that it is 1 out of 3 because there's 3 triangles.
There's 3 triangles. Every way I can make triangle 1 the biggest, I can make triangle 2 the biggest or triangle 3 the biggest. So because we have symmetry here, which is a really important concept in math, I know I'm going to have 3 triangles. Each one of them could be the biggest, and therefore each one is the biggest 1 out of 3 times. Does that make sense?
Yes.
Okay, good job. That's a hard concept to start to understand.